Shri Gurubhyo Namaha, children. Welcome you for the online teaching academy, Ekalaiva. Today we are going to continue with 10th standard science, acoustics. Today we are going to learn about Doppler effect. Now to start with an example for a Doppler effect, I wanted to give you an example of the whistle of a fast moving train. Now it appears to increase in pitch when it is nearing a stationary listener, and it appears to decrease as the train moves away from the listener. So there will be an apparent change in frequency of the sound that is produced by the train. The same effect can be observed on an ambulance siren. Now, when the ambulance is nearing a stationary observer, the frequency of the siren was found to be increasing, and when it leaves when it leaves away from the observer who is still stationary, the frequency was found to be decreasing. So there is a change in frequency. So this was first observed and explained by Christian Doppler. He was an Austrian mathematician and also a physicist. So he observed this phenomenon and he termed this effect as Doppler effect. Now the definition for a Doppler effect is as follows. Whenever there is a relative motion between a source and a listener, the frequency of the sound heard by the listener is different from the original frequency of the sound emitted by the source. So this is known as Doppler effect. Doppler observed that the frequency of the sound as received by a listener is different from the original frequency. Now this will happen only when there is a relative motion between the source and the listener. Okay, so what will be the possibilities? Now we said that there will be a relative motion between a source and a listener. Now let us discuss what are the possibilities of the motion between the source and the listener. So we have discussed here 4 cases, children. The first case is the listener moves towards or away from a source. Now here itself this can be divided into 2. One is the listener is moving towards the source which is stationary, or the listener moves away from the source which is again a stationary source. Here we can discuss 2 cases. Now look at the next one. The source moves towards or away from a stationary listener. Here the listener is stationary. The source either moves towards the listener or the source moves away from the listener. So this is the second case. The third one is both source and listener, they move towards or away from each other. Now the first case will be source and listener, they will be moving towards. The second here will be the source and the listener moving away from each other, right? And the fourth is the medium moves when both source and listener are at rest. Here the source and listener are at rest. Which is moving is the medium. But for our convenience, here we have taken the velocity of the medium to be 0. The medium is considered to be at rest. Okay. So let us discuss all these cases one by one. Okay. So to start with, source and listener are moving. we are going to find out the apparent frequency. Apparent frequency in the sense how the frequency is changing from the original frequency. Okay, due to the relative motion between the source and the listener, the frequency is changing. So the changed frequency is nothing but you call it as apparent frequency. Now let us have a generalized equation for apparent frequency, which is given as children. N dash is equal to V plus or minus VL divided by V plus or minus Vs into N. So here N dash represents the apparent frequency, that is the change in frequency, right? So this is called as apparent frequency, and V be the velocity of sound, okay, and VL represents the velocity of the listener, okay, L represents listener, and Vs represents the velocity of the source, and finally N represents the frequency, that is the original frequency, actual frequency of the sound. So these are the notations that are used here. So this will be the generalized form. Now this plus or minus will change depending upon the position of the source and the listener. Okay, so let us move on to the first case where the source and listener are moving. Now here we can consider the above situation can be divided into two. Okay, now here I said source and listener are moving. So we can consider how many cases here, subdivisions we can consider here, children. Now they will move towards each other and they will move away from each other, right? So this is one type here. The source and the listener are moving here. Now in this first subdivision I can consider is they move towards each other. Okay, so position will be, case is the same here. I'm going to consider four sub cases here. Now here case is 1, source and listener are moving. Now look at the position here. Here is source and listener. They are moving towards each other. So that is the first case we are going to discuss, moving towards each other. Then source and listener moving away from each other, right? And here source and listener move one behind the other. Now this is also possible, right? Move one behind the other. Now here I'm going to consider source follows listener. Okay, ma? And the fourth one is again source and listener move one behind the other. Now this time listener follows source. Okay, so this will be the next condition, right? Listener following the, so listener follows source, right? Okay, now I'm going to just represent it through a, just for your better understanding. So let me draw here. Now let this be the source and here listener. Okay, ma? Now you have to remember certain things when you study Doppler effect. Now whenever I write source and listener, source is always on the left side and listener is always on the right side. Okay, so let me represent the position of the source and listener through arrows. Okay, now here source and listener are moving towards. Towards means they move towards each other. So source is moving towards listener and listener is moving towards source. So they are moving each towards each other. Now in this case, I'm going to write an expression based on the general equation given here with respect to the position. Now this general equation, I need to add that plus and minus sign with respect to the position of the source and listener here, children. So let me write the formula. N dash is equal to, I will have V, it should be plus or minus, right? So V plus or minus VL by V plus or minus Vs into the frequency of the sound. Now I need to put plus or minus depending upon the position. Now here look at the diagram here once again. Now since now here, so you have to remember once again, whenever that arrow moves from left to right. Now here look at this. Now this is left side, this is right. Now the head, okay. So the arrow head moving towards right. Now this value is to be taken as negative. And the arrow head moving towards left, this value should be taken as positive, children. Okay, so let us consider the velocity of the source be Vs and the velocity of the listener be VL, right? Now here I need to put, now this is constant as I said you. Now I need to put plus or minus here. Now what is the value here? Here it is velocity of the listener here, children. So velocity of the listener, now he is moving from right to left. So right to left, it is taken as positive here. So I will have a positive sign here. Now look at the source here. The source is moving from left to right. Okay, so whenever the movement is from left to right, I need to put a negative sign. So here I have minus. This is a short method you have to remember. So look at depending upon the movement, you need to put the plus and minus here. So it will be easy for you to remember, children. So source and listener moving towards each other. So they are moving towards each other. Now source here, the arrow is towards right. So towards right, you have a negative sign. Here the listener, the arrow is towards left. So you have a positive sign. So this will be the expression for the apparent frequency when the source and listener are moving towards each other. Okay, ma? Right. Now let us talk about this distance and frequency after writing the equations for all the four subcases here. Okay. Now next is source and listener moving away. So again, let my source be here and listener here. Now this time they move away from each other. So here listener is moving away from the source and the source is moving away from the listener. So this is the case. Now let me write the equation again. N dash equal to V VL divided by V Vs into N ma. Okay, now I need to substitute, put whether it is positive or negative. Now look at again listener. Now listener, he is moving away from the source. Look at the arrow here. The arrow once again it is moving from left to right. Okay, so left to right, it is taken as positive, negative. So I will have negative sign here. Now here look at the source, it is moving from right to left. So right to left, it is positive. So I will have positive sign here. Okay, are you able to understand now? So now this is the equation for apparent frequency. N dash is equal to V minus VL by V plus Vs into N. Is it clear? So arrow moving towards right, arrow moving towards right is taken as negative. Okay, so I have put a negative sign here. Now here arrow moving towards left, it is taken as positive. So I have a positive sign here. Are you able to understand? So this is very important. Okay, the next, what is the next case? Source and listener move one behind the other. So again, source here, now listener here, they are moving one behind the other. So let us consider the listener is moving in this direction. Source is also following the listener. So S follows L. S follows L in the sense this should be the position of the arrows. Am I right? Listener is moving towards the right. Source is also moving towards the right and source is following the listener. The arrow depicts the source is following the listener. So what will be the equation now? n dash equal to, again I have V, VL divided by V, Vs children into n. Okay, ma. So here also arrow moving towards right. Here also arrow moving towards right. So in that case, both numerator and denominator I will have negative sign. Clear? Next, what is the position of source and listener here? Again, source. Now, whenever I write source, I always write to the left hand side and L on the right hand side, right? So, source and listener move one behind the other here also, but this time listener is following the source. So, let us consider the movement of the source is in this direction and listener is following the source. Okay, ma. So, this is the arrow. Again, let us go for the equation. N dash is equal to V, VL here divided by V, VS. Okay, into n. Okay, ma. So let us fix the signs here. Now here arrow is moving towards right. Here also arrow is moving towards right. So in both the cases, what is the sign I should put here? Now here it should be plus. Here also it should be plus. Okay, only thing is you should remember the general equation, children, and whenever you write the general equation, listener, okay, velocity of the listener should be there in the numerator, velocity of the source should be there in the denominator, and numerator you have the velocity of sound, denominator you have the velocity of sound, then substitute the appropriate signs here depending upon the position, how the movement of the source and listener takes place. Okay. Now let us come to the distance and frequency. What happens to the distance? Now look at this. Now you should understand it very clearly. Now what happens here when the source and listener are moving towards each other? Now when they move towards each other, what is the distance between the source and listener? Now the distance will decrease. Okay, so the distance will decrease. Now look at the frequency. Now here this is n dash, which is apparent frequency. Now here n is the actual frequency. Now when both source and listener, they are moving together, that is, they are moving towards each other. In this case, apparent frequency will be definitely greater than actual frequency. So n dash greater than n. Okay, so apparent frequency greater than actual frequency. So the distance will be decreasing. Next case, source and listener moving away. So when they are moving away, what happens to the distance, children? Definitely distance will be, this time it is increasing. So the distance will increase. Here let me write decreases. Okay, increasing, right. Now when they move away from each other, now when they are moving away from each other, what happens to the frequency? The frequency will be lesser. That is, the apparent frequency will be lesser than the actual frequency because they are moving away. So definitely frequency will be, that is, apparent frequency will be lesser than the actual frequency. Now here, as far as these two cases are concerned, since the source and the listener, they move one behind the other. Here source is following the listener and here the listener is following the source. So here the distance. Now here, as far as these two cases are concerned, distance cannot be determined correctly because one is following the other. So distance cannot be determined accurately here. So here I cannot predict it correctly. But here, what about the frequency? Now here, this frequency also, that is, I'm talking about apparent frequency. Now apparent frequency here depends on again the velocity of sound, velocity of source and listener. So apparent frequency depends on the velocities of source and listener. So this is about source and listener when they are moving. Hope you have understood this very clearly, right? Only thing is, remember the equation, and depending upon how the source and the listener they move, according to that you have to put this plus and minus sign, and this is very easy for you to determine. When they are moving together, distance will decrease, frequency will increase. When they are moving away from each other, distance will increase, frequency will be, that is apparent frequency will be lesser than the actual frequency. Okay ma? Now shall we move to the next case? The next case is source is at rest, listener is moving. So here also I can consider again the general here to case 2, but the position here it will differ. Now first, source is at rest. Okay ma? So source at rest. Okay. Now I can consider the listener to be moving towards the source. This is one case. Now source at rest. Okay, so let me write here. Source at rest, listener moving towards the source, towards yes. Okay, and second, again source is at rest. Now here listener is moving away from the source. So here I will write source at rest, listener moving away from source. Okay, so let me write the expression here. Apparent frequency n dash equal to VL divided by V. Now here, since the source is at rest, now I will have the velocity of source to be equal to 0. So I have only V in the denominator into N. Okay ma? So actually I will not have any plus Vs here because Vs is considered to be 0 because the source is at rest. So I need to just put the positive or negative sign depending upon the movement of the listener. Now here the listener is moving towards the source here. So arrow moving towards left. So arrow moving towards left, in the sense I have a positive sign here. Whenever arrow moving towards left, the sign should be given as positive. So here I have the apparent frequency to be n dash equal to V plus VL by V into N. Okay. Now here again for the second equation, apparent frequency will be again I have VL by V into N. But here the listener is moving away. So here look at the arrow is moving towards right. So towards right means I have a negative sign here. So V minus VL by V into N. So this is the equation for the apparent frequency. Now let us calculate the distance. Now distance here is S and L. Source at rest, listener moving towards yes, abdina distance will be decreasing. So when the distance is decreasing, frequency will be greater, that is N dash will be greater than N. Okay. Now here listener is moving away. So here the distance will be increasing and apparent frequency will be lesser than the actual frequency. Okay, so this is the second case where the source is at rest and listener is moving. Now the third case, which is the final case, again here it is case 3. When you understand this concept very clearly, then it is very easy for you to understand. Okay, so please be very, very clear on this. Understanding is very, very important. Okay, now let us go to the position here. Listener at rest, source is moving. So let me draw source here, listener here. Now listener is at rest here, children. Okay, so listener at rest. Okay, source moving towards L. Okay, so let me draw the arrow as if the source is moving towards the listener. Again, second case, again listener at rest, source is moving away from the listener. So listener at rest, source moving away, okay, from listener. Okay, now let me write the equation n dash equal to, now this time I will have v velocity of the listener to be 0. So I will not have numerator L. So I will have numerator only as v divided by v and vs here into n. Okay, ma, here velocity of the listener is 0 because listener is at rest. So here, look at the sign here, arrow is moving towards the listener. So arrow moving towards right. So I have a negative sign here. Again, the apparent frequency for this position, again V divided by Vs into N. Now here, the source is moving away from the listener. So arrow moving towards right. So in this case, I have a positive sign. Arrow moving towards the left, sorry. Arrow moving towards the left, so I have a plus sign. So this is the equation for the apparent frequency. And what about the distance here? Now distance, source is moving towards the listener who is at rest. So distance, again, this will be decreasing. Okay, distance will decrease. What about apparent frequency? Apparent frequency is more than actual frequency. Now here at this case, source is moving away from the listener. So the distance will increase. Apparent frequency will be lesser than the actual frequency. Okay, so these are the 3 different cases. Hope you understand this tabular column much more clearly than what is given in the book. Okay, so please go through the tabular column and please be very, very thorough with this formulas. Only thing is, you need not by heart all these things. Only thing is, you should understand the concept. Then you can do this without any doubt. Okay, ma? So see you in my next video with another concept. To receive our online lessons, please press the subscribe button and you will receive our latest updates. Thank you, children.